All right, ready? Let's talk about this stuff. Now, here's what I think is really a nice part of the second part of this chapter. It's so much easier. It's like, dude, why haven't we do this all year? Why don't we just have like 1,000 of these problems and that's it? It's so easy to expand and condense log and natural log. Because the only thing you really have to pay attention to, the two things you have to pay attention to, is do you have a fraction, because the denominator means something, and do you have any subtraction signs? That has to do with the expanding or the condensing. So if I was going to expand log AB and A and B are being multiplied together, pretty simple. This is going to be log A plus log B. If we had a base here, like say that's base 3, then that becomes log base 3 and log base 3. That's all it is. That seems pretty simple. Now, if I wanted to condense it, and we'll go over some condensing in a little bit, if I wanted to go from the red back to the black, if I was adding together the log and log, then the A and B become multiplied back together. So it goes backwards as well. So expand to the right, condense to the left. So anyone want to take a shot at what log ABC, where A, B, and C are all being multiplied together, would look like? There you go. Log A plus log B plus log C. It's that simple. If I wanted to condense it, if I wanted to go from the green back to the black, same idea. So what do you think? Help me out. That's a log. I don't know why it says lag or something. Log 7 plus log x. Not bad. Log 15, how am I going to expand that?
Log 5 plus log 3.
There you go. 15 is the same thing as 3 times 5, right? So I'm going to go log 3 plus log 5. If I wanted to go from the green back to the black, just multiply the 3 and 5 together. Now I know some of you are sitting there going, it's going to get way harder. It's like this, honestly, this easy. Can I move on? Wait? No? Okay. Record right. I just want to make sure I record. Yeah. All right. Take a shot at top one. There you go. Log 5 plus log x plus log y. Done. If I wanted to go from the green back to the black, what do you notice about all the signs that are with the logs in the green? Are the signs positive, negative, mixed? They're all positive. Okay, that's going to mean something when you get there. What about log 12? How can I break log 12 down? Log 12 breaks down to what times what?
3 times 4.
Okay, what does 4 break down to?
2.
You agree with that? So 3 times 2 times 2 is the same thing as 3 times 4, which is the same thing as 12.
Yeah.
Okay?
Does it matter what you do?
I'd say take it down to the prime components. And then put it in ascending order. If it's in mixed order, it's okay. It's just not as pretty. That doesn't seem too bad. Here's a quick question for you, because this will come a little bit later. How many log 2's do I have?
2.
I mean, I have 2 of these. So this is 2 log 2 plus log 3. And logarithm does what to exponents? What can a logarithm do to an exponent? Bring it down. Can a logarithm also bring an exponent back up? So this becomes log base 2 of 2, or 2 squared, log 3, which is log 4 plus log 3. So what's the real answer? This is pretty legit, as well as this one. And then realize that the logarithm power, if you have something in front of a logarithm, it was an exponent. It can come back up. May I move on? Natural log serves the exact same properties as log. So if I wanted to expand natural log, ln A plus ln B plus ln C. That's easy. Natural log of 16. 16 is what times what? 8 times 2. 8 is the same thing as what? 2 times 4. And 4 is the same as? So this is log 2, ln 2, ln 2, ln 2, ln 2. Or ln 2 to the 4th. So a couple ways we can do it. ln 2 plus ln 2 plus ln 2 plus ln 2. I have 4 ln 2's. The exponent can come back up top. ln 2 to the 4th. Okay, which answer do you want to leave? If I say, hey, expand it, I think ln 2, ln 2, ln 2, and ln 2. All good. All right. Can I introduce the F word? Fraction. It's the longer F word. Rolls off your tongue so nicely. I heard when you scream at people during road rage, it really means something. Fraction! Dude, get out of here. It's called me fraction. All right. I'm sorry. I shouldn't be that guy. I have a fraction here. Do you agree? Ready? Here we go. Because this is a denominator, it's not going to be plus. It's going to be minus. Done. Want to take a shot at the x over y? Log x minus log y. Pretty easy. Seem doable? Let's go a little further. Going back. You're fine. Top. Log 7 minus log 5. Bottom. Log 3 minus log 2. If it was natural log, ln 7 minus ln 5. All right. Can we move on? Okay. Let's combine the multiplication. A and B are being multiplied. C and D are also being multiplied. But I'm also going to have the F word. So what all is in the denominator on the top? Log A plus log B. Okay, I like it. Ooh, I forgot it. Log A plus log B minus log C minus log D. No, minus. I'll tell you why. If it's in the denominator, there will be a subtraction sign, a minus sign preceding the log. Say that one more time. If we're in the denominator, there will be a subtraction sign preceding the log. Do I have a subtraction sign preceding the log on each of those? Yeah. That's how it's going to work. So let's look at the next one below. Can we make that work? Which part is going to have plus and plus, or positives? 5 and x. Log 5 plus log x minus log 7 minus log y. And again, the reason the subtraction sign is in front of both the 7 and the y is because they're part of the denominator. Is that okay? So the nice thing is they made logarithms really nice for us. They allowed them to say, hey, if you have a subtraction sign, it's part of the denominator. If I don't have a subtraction sign preceding it, it was a numerator somewhere. So could you have like plus minus plus minus plus minus as far as the log goes? Yeah, and every time there's a minus sign, what do you know about that part? It's in the denominator. Okay. Now 15 is a composite number, right? 3 and 5. What about 28? 7 and 4. 4 breaks down. 2 and 2. So let's see if you can follow this. Log 3 plus log 5 minus log 2. Oops. Uh-oh. Log 5 minus log 2 minus log 2 minus log 7. I think that is as expanded as you can get. Yes, I have 2 minus log 2's. So I could technically say minus 2 log 2. Okay, but I think we've expanded this just perfectly. Okay?
You raise that to
Uh-huh.
2 squared, but isn't that a negative squared? Or no?
It wouldn't be a minus because you already have said there's a negative, which means it's the denominator.
Question. If it was like, I know it would work for this problem, if it was like log 7 minus log 7, would you cancel this log 7?
They can subtract that. Yep. Excuse me. It's good shoulders. All right. I'll do this next one, then I'll tell you a little silly story. How's that? All right. Want to take a shot? What do you definitely know? Log 3?
Minus
log 10 or 5 and 2
minus log 2.
Minus log 5
minus log 2
log
minus
2
log 4.
minus. There you go. Minus log 2 minus log 2. Ah, squeeze in there. Log 2. All right, hang on. Let's see if we make this right. This was positives. It's on top. Negative on bottom. Negative on bottom. Negative on bottom. Negative on bottom is 5 times 2 times 2 times 2, 40. Because 5 times 2 is 10 times another 2 is 20 times another 2 is. That worked out. So, all right. You want to hear about why my right shoulder is fantastic? So a couple of years ago, I had a nerve in the center of my spine that stopped firing, which gives me very little strength from here to here, which ticked me off because I used to have a really nice bench press and had really nice form, but this nerve stopped firing. So I go to the doctor, and the doctor puts a stethoscope on my shoulder. I'm like, what kind of doctor am I at? My heart's here. Stethoscope here isn't anything. He goes, move your shoulder. So I start doing this. Huh. So he brings in another stethoscope. That's me here. He puts it right here. He goes, move your shoulder. Start moving back and forth. Grind, 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 grind. He's like, you know what that is? I was like, other than my shoulder, arthritis. Arthritis, my shoulder? So here's what Doc tells me. Have you ever had shoulder injury? Yeah. When I was in 8th grade, I dove into third base and dislocated my shoulder. And basically, how the whole scenario took place, I was running round and second, coming to third. Hard, I think, appreciate this baseball story. I'm coming as fast as I can, and I dive. And I meet the plate, and I'm safe. But as I did that, it felt really weird on my right shoulder. And when I stood up, it was like this. I'm like, Coach! I'm standing up. Coach! He's like, what? I said, something wrong with my shoulder. He runs out to me, calls time, runs out to me, lays me down on the ground, takes my right arm, and does one of these, and pops my shoulder back into place. Which in 8th grade, it hurt for a moment, and for like 5 more minutes, and then I was good. Now I have arthritis because of that kind of shoulder injury. Because Coach, well, he put it back in place. Now, coming up on age 44, I have wonderful right shoulder. Because Coach, but you know what? I was safe. And we won the game.
All that matters.
And I will tell you that as I go back in saying, Coach, my shoulder kind of hurts. And he said, you know what? Rather than you catching we'll have you play right field. Till Charlie Moreno comes up to bat, and he's a good old left batter. So where's it coming? Right field. So it's one hop, get it? I go to throw it, and it's like, ooh, man, did that hurt. But it didn't dislocate again. It was just sore. It was a little inflamed because I popped it out, diving into third. Coach popped it back in. And now I throw. Life is good. Life is good. I'll just say enjoy while you're young. Don't worry about the injuries while you're young. It's just when you hit the age 40 bracket, things that you injured when you were young that seem to be healed, going, oh, I don't have to worry about that. Guess what? Yo.
Wait, so then how are you supposed to pop the shoulder back into place correctly? If it's not like
I don't know. He probably did it the right way. I don't know. I mean, it went back in place, never went back out of place. It's just now, later in life, it's, I don't know. I just don't know. That's a great question. I mean, it hurt when he took it and twisted my arm, and I felt a good lift up and then go back into place, and it popped again. But Coach Grimm, that was his name, Gary Grimm. Yeah, it was nowhere a slow movement. It was quick and fast, and it made a loud pop. And you know, when people are sitting there going, ooh, you know it's got to be good. All right, let's finish this up. Yes, I thought I'd give you a baseball story. I thought it'd be good. All right. So natural logs are going to do the same thing. So what do you got? ln A minus ln B. Love it. What about on the bottom? ln 5 minus ln 7 minus ln x. The minus precedes the ln and the ln because it's part of the denominator. Can I move on? All right. So now we get a little goofy. We got the exponents. Okay, remember log brings exponent down front, so this is going to do this to give me this. That's pretty easy. How can I write square root as an exponent? How can I write square root as an exponent? 1/2. So it's log x to the 1/2 power, which, how would I expand this a little bit? What's the 1/2 going to do now? Come down front. 1/2 log x. Love it. What's the 1/3 power? Or the third root is the 1/3 power, right? Which gives me 1/3 ln x. Love it. What'd I do? What did I do wrong this time? Don't blame him.
Thank you. Thank you. Don't blame me. They're yelling at me. Parker boy.
Parker boy. He's like totally retarded too. This is like multiple times he's been tardy, so he's like re-retardy. I'm so politically correct. I'm glad I'm recording for a reason. How would I write the 7th root of x to the 3rd as an exponent? How would I write the 7th root of x to the 3rd as an exponent?
1/7.
It is the 1/7, but it's raised to the 3rd, so it's going to be the 3/7. All right, so ln x to the 3/7. Is that okay? Because the 7th root is the 1/7 power, but I was already raised to the 3rd, so then multiplied. What does the 3/7 do? 3/7 ln x. What else? That look all right? Let's finish this up. All right. Oh my. This is the ultimate F word. All right, let's see. So can we go log 5? Still with me? What's this going to do? Do what?
Log x.
There you go. Plus 1/3 log x. Okay, hang on. Let's pause there. Are you okay with that? Because x to the 1/3 power is the same thing as third root x. The 1/3 comes down front. Okay. What about the next one? There you go. So plus 7 log y plus 2/3 log z minus, good, minus 1/4 log w. Is anyone sitting there going, whoa, where did all this just come from? Okay. So let's go slow. Here, let's go part by part. Are you okay? Are you okay here? You okay? Yeah, I'm just, see the blue underline? Over there. Is everybody okay that this is the same thing as x to the 1/3 power, which means the 1/3 comes down front? Anyone stuck there? Is everybody okay that this had the exponent come down front? It's still plus because it's part of the numerator. That's the top. What about here? Plus log z to the 2/3. The 2/3 comes down front. What about the denominator? It's minus because it's denominator. It's 1/4 because the 4th root of w is w to the 1/4 power. So even the big old nasty looking problems looks expandable. Can I move on? All right, now we're going to condense. Ooh, squeaking. Sorry. All right. Log 30. I like it. Over 6. Do you agree? Because technically this is log 5 times 6 over 3 times 2. Can I reduce 30 over 6?
15 over 3. Yes.
Not 15 over 3. So look at that. It was simplified nicely just to log 5. Why is that? Because 30 over 6 is 5 over 1, which is just 5. So we get log 5. What do you think? Did you get your phone? So I took a digger. All right, let's try it. Let's go slow. Okay, let's put a log up there. What's 2 to the 3rd? 8. Okay.
Yes.
Times
How'd you get that? I'm lost.
25. 2 to the 3rd is 2 times 2 times 2. Minus, or over.
27.
There you go. Like it. Are there any factors of 8 and 25 that will go into 27? No? So what's 8 times 25? 200. There you go. That's it?
Is this on homework?
Uh-huh.
I like this. I like this.
I told you the second part of this chapter is like cake. I like cake. I got a birthday coming up.
December 20.
December 30th. 18 days.
Wow.
Expecting y'all to throw me a surprise party.
Do you celebrate twice or do you celebrate once?
Dude. Here's the nice thing. My wife
Yes.
recognizes the abuse of my family of going, oh, here. You know, open up gifts during Christmas going, that's your birthday present too? So when my birthday comes, there's nothing.
Yeah.
My wife gets it, and my wife's family gets it. So I don't invite my parents to my birthday anymore.
Never.
Seriously. They don't even come to Christmas. I'm like,
Banger.
What?
all right. Here we
It's
go.
Christmas.
So sometimes the exponents might get a little too big. to worry about, right? When does a number get too big? I think when it starts hitting scientific notation on your calculator, I think that's too big. Or when your calculator says dimension too large, I think that's too big. Then you just leave it as exponents. All right, so let's go through this one. I know I'm going to get ln 6 to the 5th. You guys okay with that?
Yeah.
Over.
What else is on top?
5 ln to x.
Okay, so this is also on top. So that's going to be x to the what? 5th. This is also on top. What is that?
ln y. Or square root of y.
There you go, square root of y. Why is it square root of y?
Because it's 1/2.
It's y to the 1/2. The 1/2 power is the same thing as square root of y. Cool. All right, what's it all over? What? I heard it.
4.
4.
ln 4.
Done.
I got it.
Oh, I think you guys are gonna knock this second part out of the park. Yeah, another baseball thing. Sorry. Can I move on? Can I finish? I'm almost done. Oh, wait. I'm done. Woo! All right, let's go through this. All right, get to a page. This is going to be your assignment. Yeah. Page 396, 2 through 76, EOE, which means every other even. I'll tell you what, though. I'll tell you what. If every other even is too hard to figure out, just do all the evens, and you'll get it. And then 78, 89 through 91. I think it's going to be a quicker assignment. So here's the nice thing. If you're done, you get a start. Okay, let me kill this thing. Only 20